Hi everyone, and welcome to the first of 4 videos going through some past exam questions on the topic of strong bases and Kw. The first question we've got here is an acid-base pairs question. Acid-base equilibrium is set up when ethanoic acid is added to water. Okay, so we've got our ethanoic acid and water, and what's going to happen is the ethanoic acid is going to donate a proton to the water. So this is probably the easiest example of one of these we've seen. Sorry, it's going to donate a proton to the water. What am I writing? H3O plus. Okay, so it's given its proton to the water molecule. Label the pair. So this is obviously the acid, and the water is the base. And so then this is the conjugate base of that acid. So let's give those two the same number. Let's call that base 1, acid 1. So this is base 2, and this must be acid 2. An aqueous solution of ethanoic acid has the pH. The solution contains both hydrogen ions and hydroxide ions. It's a bit of a strange question. How can a solution of an acid contain hydroxide ions? Well, they're not coming from this, are they? There's no, you don't lose OH minus off of your acid. That's definitely not what's happening. The hydroxide ions are coming from the water. Okay, so OH minus ions come from dissociation of water. Right, and that happens very rarely, and there will be a very, very low number of hydroxide ions, but there will be some. Right, it then wants us to calculate the concentration of hydroxide ions. So we're hopefully looking for, this should come out as a very, very low concentration, right? Okay, so if it's about hydroxide ions, it's about a base. So therefore, we're not going to use Ka, we're going to use Kw. So we're going to start by writing out the expression for Kw. Okay, and then it wants us to calculate the concentration of hydroxide ions. So we're going to sort that out, rearrange it. So the OH minus concentration is going to be Kw divided by the H plus concentration. So Kw is 1 times 10 to the minus 14, and the H plus concentration will be 10 to the minus pH, 3.06. So if we calculate this, 10 to the power of minus 14 divided by 10 to the power of minus 3.06. And we've got 1.15 times 10 to the minus 11. Okay, so it is what we expected, right? It's a very, very low concentration of OH minus ions. Okay, so there are some OH minus ions in this solution, but really not many at all. Okay, if we have a look at this here. So they do kind of mix up some acids bits with some Kw bits. So what have we got here? We've got some potassium hydroxide, okay. What is meant by a weak acid and a bronzodilary acid? This is a bit mean because they're asking us 2 things, they're only giving us 1 mark. But a weak acids only partly dissociate. And a bronzodilary acid is a proton donor. Okay, calculate the pH of potassium hydroxide. Potassium hydroxide is a base, so if it's a base, we're going to use Kw. It wants us to calculate the pH, so therefore we want the H plus concentration. So that's going to be Kw divided by OH minus. Kw is 1 times 10 to the minus 14. Remember, it is on the data sheet, so it isn't actually something you need to learn. And then, because potassium hydroxide is a strong base, it's going to completely dissociate. So if the concentration of potassium hydroxide is 0.5, the concentration of OH minus ions is 0.5. Okay. So therefore, the H plus concentration, well, if we're dividing by 0.5, we're timesing by 2, right? So it's going to be 2 times 10 to the minus 14. And then the pH is going to be the negative log of that. So if we do negative log of 2 times 10 to the minus 14, we're going to get, does it say do it to a certain number of decimal places? No, it's usually 2 decimal places. So we'll call this 13.70. Is that a sensible value for the pH of potassium hydroxide? Yes, we're expecting it to be a high pH, aren't we? Because it's a strong base. Right, and then now we're back to a Ka type question, so they will kind of mix and match. So write the expression for Ka for this. Okay, so Ka is H plus, and again we need to use the actual formula. Don't just put A minus. C2H5COH. Calculate the pH of this solution. Okay, so if we want the pH, we want the H plus concentration. Okay, if this is propanoic acid, so it's a weak acid, so therefore we can do the same trick we've done quite a lot, where we're going to turn this into H plus squared. So we're going to say Ka is H plus squared. We're then going to rearrange that. And we end up doing the square root. Okay, if you've watched the videos on the acids and Ka topic, you should hopefully be very familiar with this by now. Right, so then we want to substitute in the values. We need the concentration and we need the Ka. But the concentration, they've diluted it, look, haven't they? So the concentration was 0.48. Okay, they've now diluted it. So what you can do here is you can be clever and say, look, if it was 25 centimeters cubed and it's now 100, the volume has been multiplied by 4. So therefore the concentration is going to be divided by 4. Okay, but I'm going to do this the slow way around, because if it was 25 centimeters cubed and it was now 85, then it's not as simple as just going, oh look, it's been times by 4. So I'm going to do this deliberately the long way around to show you the method that will work in any situation. You know, or if this is like 26.7 or something, if it's come from a titration, that's going to be awkward. So let's do it the slow way around. So what we can do is we can calculate moles. So if we say 25 over 1,000 decimeters cubed times 0.48 moles per decimeter cubed, 25 divided by 1,000 times 0.48, 0.012 moles of our acid, and then we can do the moles divided by the new volume. Okay, so this is our new concentration. Okay, and it has been divided by 4, right? Because the volume times by 4, the concentration divided by 4. So we could have done it that way, that would have been much quicker. But this method will work in any situation. Okay, so now we can say that our H plus concentration is the square root of 0.12 times the Ka. Where's the Ka value? Oh, right up here at the top of the page. Yes, they have given it to us there. 1.35 times 10 to the minus 5. Sometimes you do have to go looking for that information. So therefore the H plus concentration is 0.12 times 1.35 times 10 to the minus 5. Square root of that. 1.27 times 10 to the minus 3. So therefore the pH is the negative log of 1.27 times 10 to the minus 3. Which is 2.89, so it's 2.90.